All right, welcome to B2B Basics to Brilliancy. You're joining us for season two, where the main objective is to unpack all of the grade 12 trigonometry work. We have covered episode one for basics, principles, and concepts to make sure that the foundation is firm within trigonometry. And then we have covered episode two, whereby you're given pieces of information. Then you're required to sketch a diagram and answer questions based on that diagram. You're joining us today for episode three, whereby we unpack those questions where you can be given a trigonometric expression and then you are required, therefore, to simplify it. All right, let us get into it and enjoy the episode. So here we are given 2 sine minus 20 degrees times sine 160 degrees minus cos 40 degrees. Then the task is to determine, without using a calculator, the value of this expression. So before we even go and attempt the question, we will just recap briefly. In episode one, we learned about the cast diagram and the reduction formulae that are contained within the cast diagram. So we studied that, therefore, the core purpose of the reduction formulae is to then reduce angles like 160 degrees. Reduce that angle into an angle between 0 and 90 degrees. That is the core purpose of reduction formulae. To reduce an angle into an angle between 0 and 90 degrees, into an acute angle. Yes. So that is answering the question of what to use. We want to reduce 160 degrees. What are we going to use? We're going to use the reduction formula. Then there is another question of how to use this reduction formula. Then the answer for that is the three-question method. We're going to ask ourselves, for example, in 160 degrees, we're going to ask ourselves, 160 degrees is on which quadrant within the cast diagram? And 160 degrees is in the second quadrant. So we will then write here that as the answer. So 160 degrees is in the second quadrant. And then we ask ourselves a question of, within the second quadrant, which reduction formula are we going to use? So we have 90 degrees plus theta, we have 180 degrees minus theta. Both of them, provided your steps are correct, will lead you to the correct final answer. However, one of them can be quicker and one of them can be a reduction formula that will give you sort of more steps than the other. So preferable, you would love to select the one that will give you uh, a quicker approach to your answer. In this case, that would be 180 degrees minus theta. And then the question that arises, therefore, is what is the value of theta? But nonetheless, we will go and illustrate all of that within this specific question that we have. All right. So a question of what to use the reduction formulae. And then a question of how, that is the three-question method. So let us demonstrate how to use it. There we have 2, and then we have negative 20 degrees, which is the same as negative theta in the fourth quadrant. Therefore, that means, what is the sign of sine in the fourth quadrant? That is negative. So we are then going to have negative of sine 20 degrees. Yes. And then We want to reduce now this 160 degrees. How are we going to go about that? We will say sine and then open brackets. We ask ourselves the first question. 160 degrees is on which quadrant? As you have seen before, it is on the second quadrant. And then we ask ourselves the second question. In the second quadrant, which reduction formula do we have? We have 90 plus theta, and also we have 180 degrees minus theta. Either option, you will eventually arrive at the same answer. But 180 degrees minus theta is preferable in this case as the quickest to get to the answer. So we will then, when we are at step 2, substitute there within sine by 180 degrees minus. Then we have a dilemma here. What value are we going to substitute here? Which is the value of theta. So simple put, the question is this. What is the angle that I can subtract from 180 degrees to get 160 degrees? I will repeat. What is the value or the angle that I can subtract from 180 degrees to get 160 degrees? And that, folks, is calculated this way. In your calculator, you will say 180 degrees from the reduction formula minus 160 degrees from the angle that we are trying to reduce. And that will be equal to 20 degrees. So basically 20 is the value of theta. We will then substitute in the place of theta by 20 degrees and then minus. At the moment, we don't know if it is wise to convert that 40 degrees. Why? Because 40 degrees is already between 0 and 90 degrees. So the core purpose of using reduction formulae is to reduce an angle so that it can be between 0 and 90 degrees. And on this case, 40 degrees is already between 0 and 90 degrees. We can obviously change it sometimes to 50 using 90 degrees minus theta. But is that necessary? That's a good question. So if we have not spotted the necessity yet, we should not change. Let's keep it that way until we see the necessity. Perhaps we're not going to even use 90 degrees minus theta to change it to 50. Perhaps we will use a double angle. Perhaps we will use a compound angle. Who knows? At the moment, we don't see the necessity, so let us keep it that way. We should not change just because we know how to change. We should change when we see the necessity to change. All right. Then the negative will come to the front, and then we have sine 20 degrees. This is our lovely second quadrant, and sine in the second quadrant is positive. So we have ourselves sine 20 degrees minus cos. Then now it looks like there is a necessity to change 40. And by looking at the trigonometric ratios in the first term, we can identify that there are similarities there. The first angle is 20 degrees. The second angle is 20 degrees as well. So it might be a good idea to change that 40 degrees and express it as 20. And that sounds like a good idea. So expressing 40 as 20, that would be 2 times 20 degrees. And that now leads to a double angle. You see, now we have changed to 40 due to necessity. Due to necessity. So you must always be careful when you change an angle that is already between 0 and 90 degrees. So minus 2 sine 20 times sine 20, that is sine squared 20 degrees. Minus. We are at a very good stage. Cos 2 times 20 degrees. That is a double angle for cos. But previously in episode 1, we studied that, actually there are 3 expressions of the double angle of cos. The first one is cos squared theta minus sine squared theta. The second one is 1 minus 2 sine squared theta. The third one is 2 cos squared theta minus 1. So we must choose among the 3. Which one are we then going to substitute here as a double angle of cos? And we must not choose any of these. We must choose based on a proper reasoning process. We must not just pick and choose, close our eyes, A, B, C, D, E, F, G. No. We must choose based on a proper reasoning process. Okay, let's begin the reasoning process. The previous term, which is term 1, contains sine squared and only sine squared. That on its own is a hint. What kind of a hint? It means that when we now change the double angle of cos, we must pick among the 3 options that we have. Pick the one that contains only sine squared. There in the middle, the second one. So we're going to have now 1 minus 2 sine squared 20 degrees. Obviously, you can pick any of the 3. Eventually, provided your steps are correct, you will arrive to the correct answer as well. But it might be a bit longer than our approach. It's best to pick appropriately. Then minus 2 sine squared sine squared of 20 degrees. And then we now remove the brackets. Minus times 1, minus 1, minus times minus, plus 2 sine squared 20 degrees. And voila. Voila, folks. You see now, the first term cancels with the third term, as Malema would say. And then the answer that we have is minus 1. All right. And that is how we apply the 3-question method, folks. Just to recap, we ask ourselves, 160 degrees is on which quadrant? Second quadrant. Second question, which reduction formula is contained in the second quadrant? 180 degrees minus theta. Third question, what is the value of theta? A lot of learners make this mistake. In the place of 20 degrees, they often substitute the angle that they are trying to reduce. And that, folks, is not the right way of doing it. You cannot let theta to be 160 degrees. Because if you are substituting in the place of 20 degrees by 160, then you are saying theta is 160 degrees. And that is not the case. Why? Because theta is there. It is between 0 and 90 degrees. That is what theta is. Between 0 and 90 degrees. Right there in the first quadrant. Between 0 and 90 degrees. Now, if you substitute in the place of theta by 160 degrees, that on its own should be a red flag that you are able to spot and be like, why is my theta not between 0 and 90 degrees? Because theta must be between 0 and 90 degrees. So don't do that mistake of taking the angle that you are reducing and treating it as theta. That is not how it goes. All right. Let us go into a time for an exercise. It's your time to shine now. I would encourage that you pause the video and then calculate the value of this following expression using the 3-question method to reduce 105 degrees. Now I will show the solution. Preferable, pause the video, attempt, and then you compare with the solution that I will show just now. I am assuming that you have already attempted the problem and that you were able to therefore compare with the following solution. In this case, we asked ourselves, where is 105 degrees, or which quadrant contains 105 degrees? We discovered that it is the second quadrant. Then we asked ourselves, which reduction formula is in the second quadrant? There is obviously 180 plus theta. There is also the 180 degrees minus theta. Then which one are we going to take? Preferably take the one that will lead you to a shorter, to a quicker method, which is in this case 90 degrees plus theta. You could have used 180 degrees minus theta as well, and that would be sine of 180 degrees minus 75 degrees, I think, yeah. Sine of 180 degrees minus 75. That would have worked as well. And then at this stage, as opposed to having minus sine 15 degrees, no, it wouldn't be sine here. It would be cos actually. There's cos there, so my bad. So you would have cos of 180 degrees minus 75 degrees. Cos of 180 degrees minus 75 degrees in the place of cos 105 degrees. Obviously, this will lead you to negative cos of 75 degrees. So now you will have 75 degrees and also have 15 degrees, two different angles, which means now you must convert either 75 to 15 degrees or 15 degrees to 75 degrees. So that is just more work. However, with 90 degrees plus theta, the one that we have chosen, you just go directly to 100 and you just go directly to 15 degrees. So eventually, though, you'll get the same answer provided the steps are correct, but it's up to you which one you pick. All right. Thank you so much for attempting that. Let us then move into the next problem that we will use for demonstration. right? Now let us work on this problem. How do we go about dealing with this problem? Here we see that, okay, we have 5 angles. The first angle is negative 200 degrees. And previously in episode 1, we discovered that actually when you deal with an angle that is negative, something like negative 200 degrees, you must then add 360 degrees. Similarly, when you deal with the third angle here, which is negative 135 degrees, we must then add 360 degrees. So that is how we basically deal with the negative angles. So to write that, we would then say we have negative 200 degrees. What are we going to do? Add 360 degrees. What do we get? When we say in your calculator negative 200 and negative 200 degrees plus 360 degrees, you are bound to get 160 degrees. When we say negative 135 degrees plus 360 degrees, you are bound to get 225 degrees. So that is how we deal with those negative angles, like negative 135. And then let us focus on the second angle, 110 degrees. Also, let us focus on the last angle, which is the fifth angle, 230 degrees. So we will deal with those two the same way we did with the previous 105 degrees. And the first question that we dealt with, whereby we had 160 degrees. We will apply the three question method to deal with these two angles, the second and the fifth angle. However, we have 310 degrees here. No. 380 degrees as the fourth angle. How do we then deal with that? What we can see is that 380 degrees is an angle bigger than 360. So what do we do then? We subtract 360 degrees. So if it is big negative angle plus 360, if it is big angle greater than 360 minus 360, very simple. So we're then going to say, okay, 380 degrees minus 360 degrees. That, folks, specifically, that, folks, will give us 20 degrees. All right, let us then write our first step. Within our first step, we're going to say, okay, from sine negative 200 to sine 160 degrees. By now, you see where the 160 degrees comes from. You just said plus 360 to negative 200 degrees. Then we say cos 310 degrees. You keep that as it is for now. We will apply the three question method. And then you say plus, and then we added 360 degrees to negative 135. What did we get? We got 225 degrees times from cos 380 to cos 20 degrees times sine of 230 degrees. Yes. And folks, that is how we reduce angles greater than 360 and how we deal with angles negative, like negative 200 and negative 135 degrees. We learned about that quite a lot and extensively in episode 1. So tune in for more details in episode 1. That is where we unpacked the basics, the principles, and the concepts in preparation of problems like this. All right, now let us move along. We will then apply our 3-question method. You say, oh, okay, we have here 160 degrees. Which quadrant has 160 degrees? Previously, we saw that it is the second quadrant. And then we ask ourselves, which reduction formula is in the second quadrant? In this case, we will use 180 degrees minus theta. So when we are at the second step, we can then come here and say, oh, okay, 180 degrees minus theta. But what is my theta? What is this angle here that I can subtract from 180 degrees to get 160? I think we have seen that before. That is 20 degrees. Right. Nice and easy. And then we go to 310 degrees. How do we deal with that? We say, oh, okay. 310 degrees is on which quadrant? 310 degrees is on which quadrant? Then the answer is correct. Yes, it is in the third quadrant. That is where 310 is. All right. Then we ask ourselves, within the third quadrant, which reduction formula do we have? Negative theta in this case is not going to help us with anything. Let us use 360 degrees. 360 degrees minus theta. When we perform the 3-question method, really we don't focus much on the negative theta. We focus on 360 degrees minus theta. So when we are at the second step, we can come and substitute here. 360 degrees minus theta. Then our $1,000,000 question comes once more. The last question. What is the value of theta? Simple put, what is the angle that I can subtract from 360 degrees to get 310? What is that angle? That is a really good question. Here is something that you should not do. Do not substitute here by 310 degrees. That is not how it goes. Theta cannot be 310 degrees. It can't be greater than 90 degrees. So to calculate for the value of theta, we will say theta is equal to 360 degrees minus 310 degrees is equal to, therefore, 50 degrees. Therefore, we will substitute here. 50 degrees is an angle that we can subtract from 360 to get 310. That's how we get it. All right. Then let's move into 2 to 5. Tan 210, 25. We ask ourselves the same question once more. Which quadrant contains 210, 25 degrees? Or 225 is on which quadrant? And that is the third quadrant. That is the third quadrant. And then we ask ourselves, within the third quadrant, which reduction formula contains within the third quadrant, which reduction formula is contained there? Which reduction formula do we have? That is 180 degrees minus, oh, no, plus theta. 180 degrees plus theta. So then we come here and say, okay, 180 degrees plus theta. Then the $1,000,000 question is, what value must I add to 108 in order to get 225 degrees? And that, folks, is 45 degrees. So the value of theta, therefore, is 45 degrees. How do you get that? You say in your calculator, 225 degrees minus 180 degrees, and you should get 45 degrees. All right, then let us move along. We have now cos 20 degrees. Remember what we said previously. The purpose of the reduction formula is to reduce any angle into an angle between 0 and 90 degrees. In this case, 20 degrees is already between 0 and 90 degrees. Obviously, we are able to change that 20 into something else using 90 degrees minus theta, perhaps into 70. But is that necessary? We don't know yet. So if we don't see the necessity to change, then let us not change. Let us keep it that way until we see the necessity. Sine 230 degrees. Sine 230 degrees, which quadrant is that one? It is, yes, the third quadrant. What reduction formula do we have in the third quadrant? 180 degrees plus theta. So we will then come and write here 180 degrees plus theta. What is the value of theta? What angle must we add to 180 degrees so that we can get 230 degrees? And that, folks, will be 50 degrees. That will be the value of theta, 50 degrees. Then we will take that value of theta and substitute within that expression. And then, voila, we are done with using our 3-question method. So then we say, okay, this is the second quadrant, and sine is positive in the second quadrant. So we have sine 20 degrees. This is the fourth quadrant. Therefore, cos is positive in the fourth quadrant. This is the third quadrant, and tan is positive in the third quadrant. This is cos 20. Again, we don't see the necessity yet. Perhaps it's even good to have 20 because we also have 20 even here. Perhaps it is good. So we don't see the necessity, therefore let us not change yet. Let us not change yet. And then we see 180 degrees plus 50 degrees is the third quadrant, and sine is negative in the third quadrant. All right. Then let us move along. We can keep sine 20 degrees. Why? Because there is cos 20 this side. We can keep cos 50 degrees. Why? Because there is sine 50 that side. Then this negative is going to multiply that positive and make it negative. Tan 45 is 1. You can press that on your calculator and check it, or you can use the special angles. And that, folks, leads us to something that we studied extensively in episode 1, which is the compound angle of sine, S C C S, the pattern. And this angle is same as that angle. This angle is the same as that angle. Therefore, we can convert all of this into a compound angle of sine. The first angle is 20 degrees. The second angle is 50 degrees. We must have a sine between 20 and 50 degrees. You see this capital letter S for sine, you can assume that to be same. Same what? Same sign. The sign that we have between those two terms must be the same sign that we have between these two angles. Same sign. All right. Then we are going to have sine 20 degrees minus 50, that is negative 30 degrees. And negative 30 degrees is like negative theta, sitting right there in the fourth quadrant. And then we ask ourselves, what is the sign of sine in the fourth quadrant? And that is negative. Negative of what? Of sine 30 degrees. And you press that on your calculator, or you use the special angles that we studied about in episode 1 to find the value for sine 30 degrees. And folks, that is how we solve that question. All right. The use of the three question method, and also the use of adding 360 degrees in angles that are bigger or that are negative, angles like negative 200, angles like negative 315, and the use of subtracting 360 degrees from angles that are bigger than 360. That was lovely. That was lovely. It's your time to shine. Please do take a moment to attempt this question. I will show therefore the answer or the solution just now. Pause the video and then attempt this question. All right. You have yourself there 400 degrees. Here is a hint. That angle is bigger than 360. 320 degrees, three-step method. Negative 20 degrees, theta. So I'm assuming now that you have already attempted the question and that eventually you arrived at root 3/2 as the final answer. Yes. All right, let us move into a different kind of a question now within Simplify still. Now, within these questions that we have until the end of this episode, They are not just numerical angles, but they are also variable angles like x, negative x. So these are more or less of reduction formulae. But not all of them are the normal reduction formulae. For example, 90 degrees minus x, it is the normal formulae in the first quadrant. 90 degrees minus x is the normal formulae in the first quadrant. Minus x is the normal reduction formula in the fourth quadrant. However, minus x minus 360 degrees is not part of the normal formulae that we have. And that's a problem. So part of this question is to then restructure this thing minus x minus 360 degrees. Handle it such that we can make it the same as one of those in the reduction in the cast diagram. Right, then the question is how? How do we do all of that? And you have asked him a really, really good question. All right, let us begin. This 90 degrees minus x represents the first quadrant. Perhaps I can rewrite this so that it can be a bit bigger. I am thinking you might not be seeing that square. So it's important that you do see everything. Let me rewrite it. Minus sine squared 90 degrees minus x minus tan x cos negative x sine minus x minus 360 degrees. All right. So we have ourselves 90 degrees minus x, which represents the first quadrant. And sine in the first quadrant is positive, and we have sine and cos. What does that mean? We must therefore change sine into cos. All right. Minus, we have tan x. Perhaps we might need to change that into sine over cos, but is there necessity so far? Not yet. Let us see, after we have dealt with the right side of this expression, and see what do we get. Minus theta, minus x is representing the fourth quadrant, and the sign of cos in the fourth quadrant is positive. So that will be cos x. And then we have this monster here, minus x minus 360 degrees. Then we must add 360 degrees. Why? Because this 360 here within the brackets is negative. So we don't want negative angles here. Negative 360 degrees plus 360 degrees. That gives us 0 degrees. So what does that mean now? That means we are left with sine negative x plus 0 degrees. But there's no need for us to write down the 0 degrees. Negative cos squared x. Now we see the necessity to change this term. Why? Because we are going to cancel the cos in the denominator for tan with this cos next to tan. So we'll say sine x over cos x times cos of x. Then we have for ourselves a fourth quadrant, which is negative x. What is the sign of sine in the fourth quadrant? It is negative. All right. Then we have negative cos squared x. The negative will come and multiply with this negative, giving us a positive. Then the cos and the cos will cancel one another. Then the sine and the sine will multiply one another to then give us a sine squared x. Now we see this looks like a double angle, of course. But the double angle, of course, is always in this nature. Cos 2x is equal to cos squared x minus sine squared x. That is the double angle, of course. So we must then do something. We must take out the negative as a common factor. Then we are left with cos squared x minus sine squared x equal to minus cos 2x. And that, folks, is how it goes. Right. Take advantage of this problem. It's your time to shine. Attempt it, and then right about now, I will then show a solution. So I do assume that you have already attempted the problem, and then you can pause and then compare it with your solution. Right. So for this episode, we are left with two questions that we will finalize with, this one being the first out of the two. Let us attempt this one. All right, let us solve it together. Let us solve it together. So here we are given sine of 180 degrees minus theta, sine 400, blah, 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 blah. So we must always be able to identify the reduction formula that we are given. Remember at the beginning of this type of questions, I said we will have the normal reduction formulae like 180 degrees minus 360. We know that is in the second quadrant. It is part of our normal or standard reduction formulae. Similar to negative theta, that is in the fourth quadrant. Also similar to 360 degrees, that is in the fourth quadrant. So those three are part of our normal or standard reduction formulae. So we really don't have to do any busy work there. However, with regards to the reduction formula, 540 degrees minus theta, that is not part of our standard or normal reduction formulae. So that's a problem. But where is the problem? The problem is with the 540 that we see there. But is really that a problem? Remember, 540 degrees is just a number greater than 360. So what do we do with it? We subtract 360 degrees. And then what do we get? We get 180 degrees. So what does that mean now? It means within that 540, we must subtract 360 and then get 180. So now in the place of 540 degrees, we are going to substitute 180 degrees. And that is part of the normal or standard reduction formula. What about this guy? Eta minus 90 degrees. That's a problem. It's negative 90 degrees. You might be tempted to add 360 degrees. Well, I would love to introduce you to a different method. Let's begin here. What would you do with cos of negative a? What would you do with that? Well, you would say negative a is the fourth quadrant. So cos in the fourth quadrant is positive. Therefore, our answer here is going to be cos a. So that is how you would deal with cos of negative a. Okay, with that being said, then how do we deal with cos of 90 of theta minus 90 degrees? We will then rearrange here. Let us begin with the numerical angle, which is the negative 90 degrees. We will begin with that one, followed by plus theta. So what we have done is just to rearrange. Begin with the negative 90 degrees and then end with the variable angle, which is theta. Then what comes after that? It is a common factor of negative. Once we take out that negative, then we will be left within the brackets with 90 degrees minus theta. 90 degrees minus theta. Now, assume that this 90 degrees is in the position of A. Assume that is A. This 90 degrees minus A, minus theta. Assume all of that is A. What does that mean then? It means here we therefore now have cos of negative A. We have cos of negative A. How would you deal with cos of negative A? You remember that first question. It was equal to positive cos A. So similarly, even here, we are going to say cos of A. But we don't have A here. We are dealing with 90 degrees minus theta. That is how we would convert this reduction formula that is out of space back into space. So that 90 degrees minus theta now, it's something that we are familiar with, which is the reduction formula in the first quadrant. All right. So that is how it goes. So we know now how to deal with each and every reduction formula in that expression. Therefore, we can start solving. We can start simplifying. A sign in the second quadrant is positive, so we have sine of theta. Sine, then in the place of 540, we replace 100 by 180 degrees minus theta. Cos, then we know how to change this 90 degrees, this theta minus 90 degrees into 90 degrees minus theta. We have demonstrated how did we get there. It's no longer a confusion anymore. And then tan in the fourth quadrant is negative. And then sine in the fourth quadrant is also negative. But be careful. Be really, really careful. So there we have sine squared 360 degrees minus theta. The square, that is why we must be careful, because of the square. So simple put, this is sine 360 degrees minus theta. The square is outside. Then within the brackets, we have got ourselves sine of 360 degrees minus theta. What is this quadrant? That is the fourth quadrant. But what is the sign of sine in the fourth quadrant? It is negative. So the negative itself is within the brackets. So what did I mean now? That be careful. This negative, as much as sine is negative in the fourth quadrant, this negative will disappear in the next step. Why? Because of the square. The square neutralizes the negative into a positive. So that's why I said be careful. Here, as much as the sign is negative in the fourth quadrant, but when we come and substitute here, that negative must be inside the brackets and with the square outside. Very important. All right, let's move along. Then we have sine theta. This angle 180 degrees minus theta represents a second quadrant, and sine in the second quadrant is positive. So we have sine of theta. And then times this angle, 90 degrees minus theta, is in the first quadrant. It's one of our normal reduction formulae. Then now is cos in the first quadrant, positive. Then we have cos and 90 degrees. What does that mean? It means we must change it into sine. Then all over negative tan theta times sine squared theta. What happened to that negative now? It was then neutralized by that square. Really important. So the sine squared in the denominator will cancel with this sign and cancel with that sign. So what are we left with, therefore? We are then left with negative sine theta divided by tan theta. Why do I change now the division line into a division sign? It is because I am going to change this tan. Change it to what? I am going to change it into sine theta over cos theta. So that on its own is a fraction. Having fractions under fractions, that's a very big problem. So preferable, the moment you want to include or the moment you want to introduce a fraction, whether in a denominator or in a numerator, preferable, change the currently existing division line into a division sign for simplicity. Then, therefore, you can introduce the fraction. And then now it's simple to see that, so we changed the division sign now into a multiplication sign. Therefore, we are going to flip as well the contents of tan from sine over cos into cos over sine. Then it's easy to see that the sine and the sine will cancel one another, and voila, we are left with negative cos theta. That is how it goes, folks. That is how it goes. All right. So just to recap, when you deal with these kind of questions, you will experience or you will be given or you will encounter normal reduction formulae like 180 degrees minus theta, minus theta, 360 degrees minus theta. Those are your normal reduction formulae. And then with these ones, you don't really have to do any manipulation. You can just use them as they are. And then with regards to the rest of the reduction formulae, you must do some work to prepare them or manipulate them into a point that they are forming part of our normal reduction formulae. How? If you have, for example, 540 degrees, you subtract 360 degrees there. What do you get? You get 180. Therefore, in the place of 540, you then replace it by 108. Then voila, you have yourself 180 degrees minus theta, which is in the second quadrant. With regards to theta minus 90 degrees, then you do some manipulation there of taking out the common factor. First, you swipe these two. First, it must be the numerical angle, which is negative 90 degrees, followed by the variable angle, which is theta. Then take out the common factor, which is negative 1, left with 90 degrees minus theta. And then just assume for a moment that in the place of 90 degrees minus theta, you have A there, which means you have minus A. So a cos of minus A, it would be cos A. But what is A? 90 degrees minus theta. Then it has come back to our trigonometric reduction formulae. All right, that is what I wanted to emphasize here. Lastly, be really careful when you deal with a square. As much as sine is negative in the fourth quadrant, but the square changes everything. Keep that in mind. All right, let us go to the last question that you will take as an exercise. You can pause the video and then you attempt, and then you can therefore compare the solutions that are to come. So, for example, you have 90 degrees plus theta here. That is in the second quadrant. It's part of the normal reduction formulae. And then all of a sudden, you have theta minus 360 degrees. That is not part of our normal reduction formulae. That's a problem. And where is the problem? Minus 360 degrees. So what must we do? Add 360 degrees. Right? Then in the denominator, you will eventually apply your compound angle. But without wasting any time, there is a solution for you. There is a solution for you. All right, and folks, that is the end. I've enjoyed myself. I really hope that you got quite a lot from this episode 1.
And it's a wrap, Buffet 2. Thank you for tuning in. We hope this tutorial brought you one step closer to becoming a star. If you want more, let us match you with one of our patient and passionate facilitators who will walk you through the principles and concepts at your own pace. You can also sign up for our termly virtual revision initiative, designed to sharpen your problem-solving skills and boost your confidence for school examinations. All our contact details are in the description below. And hey, they say good people shall share, so as a good person, kindly share this with your community. Lastly, kindly like, subscribe, and comment below to let us know what you'd like us to cover next. Keep improving. Keep becoming a star. The journey continues with Basics to Brilliancy, mastering the basics and mastering the art of problem solving.